motion of a charged particle entering in a magnetic field at an angle other than 0 degree, 90 degree, 180 degree. Suppose this is the plane coordinate system in which the magnetic field is along the y direction and the particle is entering at an angle. Particle with velocity v entering at an angle theta with respect to the magnetic field. It is neither 0 degree, it is neither 0 degree means it will go like this, 90 degree means it will go like this, 180 degree means it will go like this. So it means when a charged particle Q is equal to charged particle, charge of the particle, charged particle and V is equal to its velocity, theta is equal to angle between velocity and the magnetic field. It is making, see, it is inclined now. The particle is at an angle inclined to the magnetic field at an angle of theta. So now this is neither parallel nor perpendicular. Now we can resolve it. This is the velocity and this is the magnetic field. So first, now let us resolve the velocity in two components. Drawing the perpendicular, this is the hypotenuse velocity. In trigonometry we must have seen this is the velocity and making an angle theta. It means this portion will be hypotenuse into far away from this angle, that will be sine of the angle. Then this is hypotenuse nearby to the angle, it will be cos of the angle. So it will go like this. We can treat it as there is one component of velocity v sin theta in this direction and one more component in this direction, that is, this direction v cos theta and this is v sin theta. So this velocity component we convert into two components, that is, one is this one v cos theta, another one is perpendicular, so we can write it as v sin theta. It means two components, one is along the direction of magnetic field, one is perpendicular to the direction of the magnetic field. So since the velocity can be resolved into two rectangular components, one component is along the direction of magnetic field, that is, we can call it as a Vx. Velocity along the x direction, this is velocity along the y direction, v sin theta. So each are okay. Now the charged particle moving with constant, now let us see in this portion, that is horizontal, in horizontal motion, horizontal direction motion. The velocity in the, that is velocity in the horizontal direction is equal to v cos theta, that is component of this velocity, the component, and charged particle move with the constant velocity y, constant velocity v cos theta along the magnetic field, has no force act on it, no force on horizontal component that is v cos theta, which is, you can say, is equal to constant y. Why we constant? No force is asking why, because magnetic force we know F, magnetic force is equal to Q into V into B into sine of angle. Here what? Magnetic force. This magnetic force, there is the force like this. See, here there is one force this way, that is V cos theta, and the magnetic field also in this direction. So angle between them is equal to 0. So we can write in this magnetic force is equal to charge. What is the velocity part? This is the velocity part into V cos theta into magnetic field into sine of angle between them is 0 degree. Therefore, magnetic force is equal to QVB cos theta into sine of 0 degree is equal to 0. So, magnetic force in the horizontal direction or magnetic force in the x direction is equal to 0. It means what? The charged particle move with the constant velocity v cos theta along the magnetic field, v cos theta along the magnetic field, and no force act on it. Hence, this component of v, that is this component of v means this component of vx is equal to v cos theta. This component, which is component of v only, its component in this direction is v cos theta. Hence, this component of v provides linear motion to the charged particle along the direction of p. That is, this component of velocity, that is v cos theta, provides linear motion. Why linear motion? To the charged particle. Why? Because the velocity is acting this way, no force is acting on this one, and this velocity is constant. Hence, this component v cos theta of v provides linear motion to the charged particle along the direction of magnetic field, because this is providing, this velocity is acting along b and provides linear motion. That is, it provides linear means rectangular motion. Now, let us come to the perpendicular component. There is one more component, perpendicular. This is the perpendicular component. Perpendicular component of velocity vector is v sin theta. See, this is the perpendicular component. Magnetic field is in this direction. Now you see, this is the component v sin theta, and this is the direction of b, and the angle between them is 90 degree. This is the perpendicular component of v in the direction of magnetic field. So, we have already seen when the velocity with the particle moves in a direction perpendicular to the magnetic field, it undergoes circular motion. It means this component, this is v sin theta, makes the particle to move in circular motion. See, this component v cos theta gives linear motion, that is motion in this direction, and v sin theta gives circular motion to the particle, to the charged particle. This we have to remember. That is, the perpendicular component of v, that is v sin theta, provides circular motion to the charged particle as b vector, and this component of v, that is perpendicular component of v sin theta, both are perpendicular. Therefore, the particle will experience a magnetic force. So now let us see what kind of magnetic force it is giving. It will experience a magnetic force, right? Very nice. Rise sin theta. What is the magnetic force? As it is the Lorentz force, magnetic force is equal to charge into velocity into magnetic field into sine of angle. Between what? Between V and B. Now we see here, this is the direction of velocity which is equal to V sine theta. See, this V is different, this is different. Its component in the perpendicular direction is this one, its component in the horizontal direction this one, and this is the direction of magnetic field, and both their angles are 90. Therefore magnetic, this particle moving with velocity v sin theta perpendicular to the magnetic field will experience magnetic force, that is equal, it is a Lorentz force, which is equal to Q charge, which is equal to charge into velocity. What is this velocity? This is the velocity sine theta. Here the theta, what is theta? Theta is the angle between B and V. Don't confuse, and this is the component with B making an angle 90 degree. 90 degree, this component making 90 degree. Q into V into B into sine of angle between them is 90 degree. See, between this and this is 90 degree. Here you have to be very careful. So sine 90 is equal to 1. Therefore the magnetic force is equal to Q B, forgotten to write, into V. Q V into B into sine of theta. The sine 90 is equal to 0. This is the force experienced by the charged particle whose velocity is v sin theta perpendicular to the magnetic force. Now, since magnetic force, it will undergo in the circular fashion like this, circular motion, because this component will give you, because of this force perpendicular to magnetic field, the charged particle will move in circular path because both are perpendicular. So it will move like this. One velocity is v cos theta in this direction and v sin theta in this direction, give the circular motion to the charged particle. This is a charged particle moving in this direction with velocity v. So this is the velocity qvb sin theta. Now for the circular motion, if it is a circular motion, there has to be a centripetal force. Centripetal force for the body to move in the circular fashion. So it means what? The centripetal force required to move the particle in circular path is provided by magnetic Lorentz force. What is the magnetic Lorentz force? Magnetic Lorentz force is force and centripetal force, that is centripetal force is provided by magnetic force or Lorentz force. What is centripetal force? Centripetal force, the general expression is mass into velocity square mv square by r. This is the expression mv square r. Here what is the velocity here? Here the velocity where m is the mass of the particle. Here the velocity, this velocity, which is responsible for giving a rotational motion. This velocity is only giving rotational motion. And this is giving this velocity v cos theta giving a linear motion. So this velocity is v sin theta and its square divided by a radius where r is equal to a radius of the circular orbit in which the particle will move because of this perpendicular component of the velocity. mv square r is equal to What is the centripetal force? That is m v. This is v square sine square theta. V square sine square theta divided by r. This is the centripetal force. Centripetal force. Centripetal is provided with magnetic force. This is equal to qv b into sine of theta. Here don't confuse with this angle and with this angle. This is the angle made by the moving particle with the magnetic field, and this is the angle made by the vertical component of v with b. This is equal to, now we can, with this we can calculate the radius vector. What is the radius of the circular path? How we will calculate the radius path? See, radius path, what is r? R is equal to m v square sine square theta divided by q into v into b into sine theta. So this and this get cancelled, this and this and get cancelled, is equal to m v sine theta divided by qb. This is the value of r. What is r? Where r is the m v sine theta by qb. This is the value of where r is equal to the radius of circular path due to perpendicular component v sine theta, v sine theta of the velocity with b. Okay, now we have found out the radius of the circular path. Now we will find out that once we find out the radius of the circular path, we will find the time period of the revolution, because it is making one circle. It means how much time it is taking to complete one circle. That is called time period or revolution. Therefore, the v has two components, v cos theta and v sin theta. This component in this direction is responsible for the linear motion. The particle will move in this direction, and v sin theta is responsible for the particle to move in the circular fashion. It means there are two motion. Particle undergoes circular motion as well as linear motion in this direction, because the velocity v cos theta is acting in this direction. So, and r is equal to, we have found out mv sin theta by qb, where r is equal to radius of the circular path by the charged particle. So, time period, what is time period? See, velocity is equal to displacement by time. It means time is equal to displacement by velocity. Time period, we are looking for what? For the circular motion, how much time it takes to complete one circle, that is called time period. So t is equal to time period of what? Time period of one circle or one cycle, we can say one circle or one cycle to complete one revolution, that is time period, which is equal to how much distance it travel in one circle, which is equal to circumference. Circumference is equal to 2 into pi into r, time period, distance divided by its velocity. What is its velocity? The velocity which is responsible, this velocity is responsible. See, v sin theta, which is perpendicular to magnetic field B, which is at 90 degree to the magnetic field, is responsible for the circular motion. It means 2 pi r, and this is the velocity. Now we will not put v, we will put v sin theta, because this component is giving only linear motion. This component v sin theta is giving circular motion. So we will use this one, v sin of theta. So time period, we can say how much time is equal to time to complete one cycle or one circle. So time period is equal to 2 pi into v sin theta. As it is, we know the value of r. R is equal to m into v sin theta divided by q into b. So from here we will take this one and mean this v sin theta gets cancelled. Therefore time period. Therefore the time period is equal to 2 pi m divided by qb. This is the time period for one revolution. 2 pi m by qb is the time taken for the particle to complete one cycle. So here now therefore charge particle, what are the, because of this its component v cos theta, v sin theta, the charge particle is undergoing under the combined effect of two component velocities. This is one component, this is another component of this velocity. It is under two motion, one linear motion followed by one circular motion. Hence what happened? See, we can say, so due to component velocity of v, that is v sin theta, which is responsible for the circular motion, and v cos theta, which is responsible for linear motion, there is a combined motion. Hence the body, it moves along the magnetic, this body moves along the, because of the linear motion, it moves along the direction of magnetic field due to horizontal component. It means the particle will move in this direction also, and it will make, while moving, it will make circular motion also. Hence it moves along the direction of magnetic field due to the horizontal component v cos theta, that is linear motion of velocity v and of the particle, and the same time it moves in the circular path due to perpendicular component of v sin theta of the velocity. So the resultant path, how it will be? The resultant path, now we see, now we can keep like this. This is x direction, this is y direction. What will be the motion? See, a particle is moving in a circular fashion as well as it is moving in this way also. It means what? The path, it means it will keep on moving circular path and it will displace in this direction also. It means it will go like this. It means it will go in the resultant path of the particle is a helix with its axis parallel to the magnetic field. So it will make it, it will go like axis with the axis as its magnetic field. So we can say how this will go. It is going with the velocity v. So the particle will undergo a circular path. Again circular path. This is called helix. Combination of this motion, because it has got two motions, circular as well as linear motion. When is combined, it will make a circle. It will make circle not like this, it will make circle like this, and it will keep moving in this direction, linear motion also. So this called pitch P. What is pitch? The linear distance traveled by charged particle in one rotation. See, from here it makes one rotation. See, from here it goes here. It starts here, it means again it is repeating the same thing. So what is pitch? We can write pitch, P-I-T-C-H, pitch, the linear distance. This is linear distance. The linear distance traveled by charged particle. Traveled by charged particle particle in one revolution. One revolution. So that is called, we call it as a pitch. So pitch pitch is equal to what? This is the distance, this direction is v cos theta, velocity is in this. See, distance, linear distance is what? Distance traveled is equal to, what is the distance? Velocity is equal to displacement by time, this we know. And what is a displacement? Displacement is equal to velocity into time. So pitch we can write, what is pitch is equal to, we can say pitch is equal to linear distance. Linear distance means what? Velocity into time. Therefore pitch we can write, because of this velocity only it is making linear displacement, that is velocity component is v cos theta. This is the v cos theta is the velocity component, and time period into its time period. So that is pitch is equal to v cos theta into time period is equal to 2 pi r by v sin theta. This is the expression for the pitch. What is the time? 2 pi m by qb, sorry. Time period is equal to 2 pi m by, we already, because on substituting this become 2 pi m divided by qb. 2 pi m divided by q into b. So pitch is equal to 2 pi m v cos theta divided by qb. 2 pi m v cos theta divided by q. And what about the frequency? Linear frequency. The linear frequency is equal to 1 by time period, inverse of time period, that is, this is the time period, is equal to qb by 2 pi m. And angular frequency also you can calculate. What is the angular frequency? The angular frequency is omega is equal to 2 pi into linear frequency. Multiply with this 2 frequency, which is equal to 2 pi into linear frequency is equal to qb by 2 pi into m. Therefore, the angular frequency is equal to qb by m. This is the expression for angular frequency. This is the expression for linear frequency. This is the expression for time period. Time period is equal to 2 pi m by qb. So it means, in conclusion, is that whenever a particle other than 0, if a particle enter with a velocity other than, this is the magnetic field, if it is entering 0 degree, because the magnetic force on the particle is 0. If it is 90 degree, the magnetic force is maximum. Or if it is 180 degree, then also it is 0. But if it is entering at an angle, inclined angle, it will have two components. The particle will go a circular motion as well as a linear motion, and because of the circular motion, it will go like this. Because combined motion of circular and linear motion, it will go in a helical path. So the resultant path of the particle is a helix with its axis parallel to the magnetic field. The helix means its axis, this is the magnetic field. So the helix axis is magnetic field.